In this lecture presented by www.free-academy.com, we're taking another user-submitted question on concavity. This question gives us that f of x is equal to x to the fourth minus 6x to the third plus 12x squared minus 3x plus 1, and we need to find the equation of the line at the inflection points of the graph. So I'm guessing this is the equation of the line that is tangent at the inflection points. That's not worded so clearly, but that's the way I'm going to go about solving this problem. So to do this, first of all, we're going to need the inflection points, which means we're going to need the second derivative. To get the second derivative, we have to find the first derivative. Plus 24x minus 3. And the second derivative is going to be equal to 12x squared minus 36x plus 24. And then to find the inflection points, we need to set this equal to 0. Now the first thing we're going to want to do with something like this is divide out a common term, which is pretty clearly 12. So this is x squared minus 3x plus 2 equals 0. So let's see if we can factor this out. I would say maybe like minus 2 minus 1 would be our factors. So our inflection points can occur at x equals positive 2 or 1. We don't exactly have enough information yet to say that these are inflection points, but we can go about determining whether or not they are by doing our interval test. So we have from negative infinity to positive 1, from 1 to 2, and from 2 to positive infinity as our intervals. And we need to pick some test values, so I think 0, 3/2, and 3 would probably make some pretty good test values. This is our f double prime of x. So let's start off by finding 0 in this equation. If we take the second derivative and evaluate it at 0, that's going to be 0 squared minus 3 times 0, positive 2. So from negative infinity to 1, we're positive, which means we're concave up. Now let's evaluate it for 3/2. So this will be 3/2 squared minus 3 times 3/2 plus 2. And getting a little short on room, this is going to be equal to 9/4 minus 9/2 plus 2. This is the same as minus 18/4. So positive 9/4 minus 18/4 is going to be negative 9/4, which is going to be equal to about negative 2.25. And that's plus 2, so this is going to be about negative 1/4. But the important part is that it's negative, so this is concave down. Now we evaluate for our last test value, which is x equals 3. So this is going to be 9 minus 9 plus 2. That's positive. It's concave up. So our inflection points indeed are at x equals 2 and 1. So now that we found that the inflection points are at x equals 2 and 1, we need to go about determining the equation at those points. And to do that, we're going to not only need a point, we're also going to need the slope. We can find the point from our function, and we can find the slope from the first derivative. So we're not going to have any need for the second derivative anymore. So let's plug both of x equals 1 and x equals 2 into our function to get our two different points. We'll start out with 1. This is 1 to the fourth minus 6 times 1 plus 12 times 1 minus 3 times 1 plus 1. And that's going to be negative 9 plus 14, which is equal to 5. So we have 1 point at 1, 5. And now let's find the slope at 1, 5. So this will be f prime of positive 1, which is 4 times 1 minus 18 times 1 plus 24 times 1 minus 3. So this will be 28 minus 21, which is equal to 7. So for x equals 1, we have the point 1, 5, and we have a slope equal to 7. We can plug that into point slope form to get an equation of the line. So we have y minus 5 equals 7 times x minus 1, which we can now clean up to get y equals 7x minus 7 plus 5. Y equals 7x minus 2. And that is the equation of the line for the inflection point that occurs at x equals 1. Now let's do the same procedure, but let's do it for x equals 2. Switch my color here really quick. Yeah, that should be nice. So we'll start out by finding f of 2, which is equal to 2 to the 4th minus 6, 2 to the 3rd, plus 12, 2 squared, minus 3 times 2, plus 1. This is equal to 16 minus 6 times 8, plus 12 times 4, minus 6 plus 1. This is 48. That's 48. That's convenient. So those cancel. So we get 16 minus 6 plus 1. That's going to be equal to 11. So at x equals 2, we get positive 11 for our y value. Now we need the slope at this point. So f prime of 2 equals 4 times 2 to the 3rd, which is 8, minus 18 times 2 squared, which is 4, plus 24 times 2, minus 3. This is negative 72. This is 32 minus 72 plus 48 minus 3. This will be 80 minus 75, which is equal to positive 5. So now we have the point, and we have the slope is equal to 5. So we can put this into point slope form as well, and get the equation for the line. Y minus 11 equals 5x minus 2. This will be y equals 5x minus 10 plus 11. Y equals 5x plus 1 is the equation for our line at the inflection point that occurs at x equals 2. And there we have it.